Good morning, everyone. Um, First of all, once again, if you can hear me all right, just give me a thumbs up. And if you can see the screen I'm sharing. All good? Okay, fine. So before we start, uh, I'm not sure whether all of you have noticed that I have sent you an announcement regarding the tentative schedule. And I just gave you a hint that we'll soon start doing our homeworks as well. So let me share my screen so that you can see. Okay, there you go. You can see the syllabi. Okay, so that's the book. Okay, that's the syllabi. Okay. All right. So today will be the last day for problem solving. We'll go for the geometrical problems today and try to cover as much as possible. Then the next day, we'll have our first review. So soon after I finish today, I'll send you a study guide, okay? You don't need to be too worried because it will be really, really easy. If you have understood the problems, the examples I've shown so far, the homeworks I have assigned to you so far, if you're good with those, you will feel comfortable in the first exam. It will be really easy, so you don't need to be worried at all. So the next day, I mean Friday, we'll have the first review, excuse me, and then on Monday, we'll go for the first exam, okay? And for the homework, it will be available from Friday to Monday as well. That homework I've assigned in a way so that it will actually work as a practice, for the exam. If you do the homework, you'll actually be practicing the contents of the first exam. So I've tried to model those questions in a way so that it actually helps the cause. After the exam, we'll go for the topic logic, and we'll continue that up to February 22nd. And from there on, as you can see, we'll go up to May 5th for our regular lecture, and we'll have our final review on May 7th before we go for the final on May 12th. So that's the tentative schedule. I'm planning to do this, but that's subject to change, of course, because if I feel that I need to spend more time on a particular topic, I'll try to readjust it, okay? But that would be the plan, that would the tentative schedule, as I said. Okay, so before we start the geometrical problems, and the last topic from the problem solving, any question from the schedule? Anything that's bothering you or that's unclear to you that you want to make sure that you are getting this?
It's not actually about the schedule, but what is an exam in your classroom going to look like?
Okay, so you'll have free response questions for the exam, where you need to show your work, as I said during the lecture, that you need to show how did you do that, with the side notes, at each step, what you have done in that particular step, and of course the final result. I'll post you a rubric as well so that you get to know how much will you get for each of the steps. For example, if you have a question of 10 credit, it will have several parts. Let me share my iPad. Okay, just give me a second. New share. Okay. iPad. So
Do you curve your tests or no?
I'll come back to it. Just give me a second. Can you see the screen? Okay. So about curving, as I said, I generally grade really well. So I'm not going to curve each and every exam, but I'll definitely drop uh, one or two homeworks, which will help you to uh, increase the overall percentage for the homework. For the exam, I'll try to grade, you know, better so that I don't need to curve it later on, because curving is really um, um, systematic way, because you don't need to, you can't be, um, you can't create any discrepancies, you know, because whatever you do, you need to have consistency. So curving is really difficult. But yeah, if I see that someone needs just one or two credit which will change their grade, I'll definitely do that. But I'm not really going to curve any exam, because I'll grade well. You'll see once I post the exam, once I post the grades, you'll see I'll grade well, so that you don't need any curving. All right, so just one example of the rubrics. I'll post that, no worries, but I'm just showing you one example. um, if you have, let's say, a 10 credit question, so definitely 3 points will be for the final result rather. 2 could be for the formula you're using. If I can't provide the formula, I'll have a meeting with the course coordinator tomorrow. I'll ask him that whether I should provide the formula or not. If I can't provide, if I'm not allowed, then it will definitely have points for writing the formula as well. Okay. You'll definitely have 3 points for the side notes. Okay, at each steps. What else? And let's say you'll have 2 for the calculation. I mean, often in maths, we see that you reach to the final result and it's also right, but in between, you have several wrong calculations. And by some reasons, I don't know how, you still reach the final result. So for the right calculation, you'll also get 2. Okay, so for example, if you have no idea what the question wants, if you just write the formula, you'll still get 2. Okay, uh, if you can show some work that, yeah, I can do this, I probably couldn't reach the final result, but here you can see that I know the steps, you'll get 2 more. You know, this rubric works like this. Okay, I'll show the rubric. As I said, I'll post a rubric and a study guide, probably within uh, next couple of hours. Okay. Any more questions from the exam?
Will we be able to use scratch paper, or do we have to use like the computer to show our work?
Oh, for the show your work, yeah, you need to write those stuffs in that assignment. In my open math. So you don't need to write it on paper and scan it and send it to me. You can actually write those stuffs on computer. Yeah, that's a good question. Um, okay, so let's go back to the problem. Okay. Okay, so here you go. Okay, the book. Okay, can you see the book?
I can't.
Okay, so I think everyone else should be able to do the same. All right, so today we'll start geometry and we'll try to cover as much as possible. So just a quick reminder for you guys. Okay, what's going on here? Your sharing is paused. Okay, okay. So
can we go over the homework, the try it now for?
yeah, we'll go over it. So for the exam and for the homework, just a quick reminder for you guys that the problems I have already shown or I have told you to go over, you just need to cover those, okay? You don't need to see the other examples or other topics. That's quite straightforward. I don't need to repeat it in future as well. The topics, the examples, or the contents I'm not really showing, you don't need to cover it for the exam, unless I have already mentioned it, that you need to go over this, okay? So I'll have this clear in the, what is that? A study guide, okay? I'll have this completely the right direction for you guys, so that you don't get carried away, you don't get overwhelmed with other examples. So just make sure that you are getting the examples I'm showing and the try it now problems. So let's quickly go over the homework first. What was the problem? Try it now 4, this one, right?
Yeah.
Now let me share my iPad again. Oh, this switching takes a lot of time. Sorry about that. Okay, so let me stop this and start sharing this one. Okay. All right. Okay. Yeah. So, oops, something in the chat. Okay. So, the try it now 4 says that 1,000-foot spool of bare 12 gauge copper wire weighs 9.8 pounds. So that's example. So try it now. Oops. Try it now 4. Okay. And how much will 18 inches of that weigh in ounces? Okay. So the question is, what are you looking for? The first information we have is the length, which is in feet, I guess. Yeah, 1,000. Oh no, it's actually the 12 gauge. Sorry. Yeah, that should be 12 gauge. And the weight is 19.8 pounds. Okay. And we need to find how much will the 18 inches of the wear. So once again, we have another length, which is 18 inches. And we're looking for the weight. So that's the unknown part. So let's say that X. And we need to find that in ounces, right? So now, these are the informations we have. I mean, these 3. Okay, 1, 2,
I
3.
think the length is supposed to be 1,000 feet.
But it's showing foot. I mean, if it was 1,000, it should have been feet. That might be a typo. Okay, let me see.
In our conversions as well in the book. They
Is
spelled it.
it,
Oh,
is it showing foot as well?
yes, sir.
It should be feet, right? 1,000 can be foot.
Well, it's talking about one thing because it's a 1,000-foot spool. Because it's just like that's the adjective describing the spool.
Yeah, I understand. But I thought, in maths, we often use these words which is wrong, so you can't really use that information. But although I think it's a typo, yeah, because it's a problem-solving class, it shouldn't be too harsh with the questions. Yeah, that's a good point, though. Okay, so, oops, someone in the waiting room. Just give me a second. Where is that waiting room? Okay. All right. Yeah, that makes sense because how much will the, okay, of the where? Yeah, so the where is fixed. Yeah, I think that should be 1,000. Yeah, that's right. Initially, I thought that as well, but that typo, we often use that in higher classes. So, okay, all right. Okay, so these are the informations we have, and we're looking for the weight for the where the length is 18 inches. Okay. Now, how can we set up the question? So I'll not spend too much time on this because we need to go for the geometry part as well. So anyone wants to say how can we set up the question, because the rest will be pretty simple.
Convert either the inches to feet or the feet to inches.
Okay, so what have you done? Which conversion?
So there's 12 inches in a foot, so I did 1.5 feet for the 18 inches.
Okay, so yeah, so we know 12 inches gives us 1 feet, so 18 inches should give us 1.5, right? Okay, and how about the ounce and pounds?
There's 16 ounces in a pound.
Right.
So I converted it the other way. I turned the pounds into ounces. So I multiplied 19.8 by 16.
Right. Yeah. And what's the result?
Oh boy.
Okay, I can check it.
I got 316.8 ounces.
Okay. Okay, so the first thing is done. I mean, the conversion, it's really important. As you can see, we have different units. So we need to have the exact same unit on both sides. Otherwise, the result will be different. So the first job is to convert those according to our informations. So we have done that. Now, next job is to set up the equation, right? Where we can find the unknown x. Okay, someone else. Let me ask it. Where is the participants list? Okay. Okay. Dylan?
I'm here.
So can you say me how we can set up the equation?
I had set up 12,000 inches to be divided by 316.8 ounces to find out how much the wire weighs, how many ounces per inch we have.
Okay, so you have how did you get 1,200 inches?
I converted the entire spool of wire into inches.
So that should be 12,000, right?
12,000.
Yes.
Okay, yeah, sorry. Maybe I heard it wrong. Okay, yeah. So then you divided it by 19.8. Is that right?
I actually converted the pounds into ounces as
Okay,
well.
so you had 316.8.
Yes, sir.
Okay, yeah. Then
And let's make sure my calculation was correct.
so a quick reminder.
Oh, yeah, I've done this backwards.
No, it's all right. So when you already have the left-hand side, that means you know which of the proportion you are considering here, right? Which ratio you're taking here. So on your left, if you can see, we have length over weight, right? The ratio of length and weight. Can you see that? So if we have already taken length over weight, that means clearly somehow or other we need to have length over weight on our right as well, right? So that's in inches and that's in ounce. Sorry. So on our right, we'll have length in inches, which is 18, I believe, yeah. And the weight in ounces is unknown. So that's it. Is that right? Anyone?
Yeah,
Yes.
that's what I have.
Okay. Is there anyone who has a different answer, different setup than this? I mean, you could have a different unit, but the ratio should look like this, right? Okay, so if you solve it, we can cross multiply this and this. So we'll have 12,000x equals 18 times 316.8. And we're trying to isolate x. So clearly, we'll divide both sides by 12,000, right? So we'll have 18 times 316.8. This will come here because we'll divide both sides by 12,000. And what's the final result here? Okay, let me check. So that should be 18 times 316.8 divided by 12,000. So 0.4752 ounces. Okay, is this the same result? Or if you have a different one, we can cross-check that. Okay, looks like it's the result. So again, when you're working with proportion and ratios, all you need to have is the same ratio on both sides and obviously with the same units. If you have a different unit, you will have a wrong result, okay? All right, so let's move to geometry part, okay? And for geometry, if you have the book in front of you, please have that open because I can't really share two screens at the same time. I'm not sure whether that's been included in Zoom, but as of now, I can share only one screen. Okay, so again, you need to know a couple of things for solving this type of problems. If you can go to page 11, you can see you have formulas for rectangles, circles, rectangular boxes, and cylinders. And you can see some formula there. So you need to know these steps. You need to know when you are working with a circle, what would be the area, what would be the circumference, what would be the perimeter of a rectangle, what would be the volume of a cylinder. So you need to know the steps. So have that open in front of you and let's solve one or two problems before we wrap up today. Okay, so let's go to example 22. And okay, yeah, it says if a 12-inch diameter pizza requires 10 ounces of dough, how much dough is needed for a 16-inch pizza? Okay, all right. So here the most important thing is you need to understand what are the informations we have and what are the formulas we can use here. So we can see the diameter here. Now what's the diameter? So if I draw a circle, is this the diameter? No, it's the radius, right? It's the radius, and the diameter is basically this. Okay, I think I should use a different color. Yeah, so let's use this way. So this is basically the diameter. Okay, and this diameter is given for this pizza, which is 12. Okay, it is 12. So that's example 22. All right, and the weight of the dough. Now that's the point. What does this signify? This 10 ounces of dough. Which weight it's talking about? Is it only the diameter? I mean, what's this 10 ounces? Yeah, Dylan?
It makes the entire pizza, the whole area.
Exactly. That's the most important part here. So if you have seen a dough, obviously you have seen. That means the entire thing. I wish I could show you the 3D version, but I can only show 2D. So the entire, this guy, no, not guy, anyway, this material, the shaded in blue, this entire thing is the dough, right? Where we put our toppings over, we put our toppings over this thing. So this entire thing weighs 12 pounds, oh no, 10 ounces, sorry. So this is 10 ounces. Okay. Now, what does this signify, these blue lines, this shaded region? Can you relate to any geometrical aspects of this?
The area?
The area, very good. It's the area, right? Can you see that? If you draw a circle, let me redraw it for you. If you draw a circle, if you are taking all of this, that's basically the area, right? Area of a circle. Okay, all right. Now, the next information we have is how much dough is needed for a 16-inch pizza. Okay, all right. So that's the tricky part. You might be thinking that, hey, if I can take the ratio of this, where I have 12 at the top and 10 at the bottom and 16 at the top and some unknown at the bottom, right? It might tempt you, to do like this, but that's not the case because you are looking for the weight of the area. Okay, so that means we need to find that first. Okay, so quickly, let me write it for you. If you have seen this before, that's fine. If you haven't seen this before, that's fine as well. If you have a circle of radius r, the area, the area of that circle is pi times the radius squared. Okay, pi r squared. Okay, so the pizza we have has a diameter of 12. What's the radius? Let me ask someone from the participant list.
The radius would be 6.
Okay, so yeah. So whatever we have as the diameter, your radius is actually half of that. And you can actually see this from this graphical representation, right? Because your diameter starts from the center and goes to one of the circumference, one point to the circumference. It's not really joining 2 points from the circumference, but the diameter actually joins 2 of those, and it goes through the center as well. So it's actually double the amount you have from the radius. So radius, in other words, radius is half of diameter. So our diameter is 12. So let's say D is our diameter. So that means our radius is 6. If our radius is 6, what's the area? That's pi times 6 squared, right? So you can keep it like this. Let's say 36 pi. And for the other one, that's for part 1. For part 2, our diameter is 16 inch. So that means it will be 8. The radius will be 8, right? And the area will be pi times 8 squared, which is 64 pi. Any question up to this? We're trying to do it step by step, okay? If you have any question, you can go for it. I'm more than happy to re-explain it, okay? All good? Okay, so the recording off? No, it's going on. Okay, fine. So now we have area of 36 pi, and the weight of that area is, where is that? It's 10 ounces, okay? And the area of the other pizza is 64 pi, and we're looking for the weight of that. So let's say that's X ounces. Now, any question from the setup? We are still working with proportion though, but now we have moved to geometrical objects, okay? As you can see, we're still working with ratios and proportions, right? So any question from this? Clearly you can see we have area over weight, and on our right we have area over weight. So looks like I have set up the equation right. Now I need to check the units. It's in inches, it's in inches, it's in ounce, it's in ounce as well. So we are doing fine, right? Not really inches, that should be, yeah, all right. Excuse me. Okay, so if you don't have any question from this, now we can solve it using our previous concept. So we can, first of all, the reason you might be wondering why I have kept this pi. I easily could have used my calculator, used my calculator and converted it to decimals. But you might be wondering, why did I keep this pi? The simple reason I did, because when I'll set up the equation, I know I'll have pi on both sides, so I can clearly cancel those out. So my intuition says, if you can keep those and later you can cancel those easily, I think I should rephrase it. If you can cancel those later on, I think you should keep those, because that actually makes your life easier. Okay, you'll see I'll probably don't need calculator to solve it. It will save my time. Anyway, if you want to convert it to decimals, you're more than welcome. You can do that. And if you want to keep it like this, you can do that as well. Okay, so let's cross multiply. this, so it will be 36x. Okay, and it would be 640. So x will be 640 over 36. And let me now use the calculator. 640 over 36. I have 17.777. I'll take up to 4 decimals, so I can use this. So this will be my final result. Okay, 17.7778, or you might write 17.8 ounces. Okay, let me show you the entire screen. Okay, any question up to this? The calculation part is still proportion and ratios, but as you can see, before going to that, we actually did a lot of things. We have used the diameters, converted it to radius. We have then used that radius to find the area, and then we went for the proportion part. Okay, you can see there are lots of steps for solving a particular problem, and each step is equally important. If you somehow do a mistake in between, you'll get to a different result. Okay, no questions at all from this? All good? Okay then. Let's move to the next problem. Okay, a company makes regular and jumbo marshmallows. The regular marshmallow has 25 calories. How many calories will the jumbo marshmallow have? Okay, there is no other information. Okay, so they have it later on. The regular marshmallow have a diameter of 35 units and the height of 3.5 units, but that's not really given in the question. I don't really understand why they have done this way. Anyway, I'll use this information to set up the question right, and then we'll solve it. So the regular marshmallow appears to have a diameter, so that's the regular one. Example 23, that's the regular marshmallow, have a diameter of 3.5 units. The unit is not given. That's one thing to one less thing to worry about, because we don't need those conversions and all that. So that's good. And the height of 3.5. Oh, okay. So 3.5 unit. Should write it in plural. Okay, and the jumbo one, jumbo marshmallow, has a diameter of 5.5 units, so that's massive, and the height of 5 units as well. Okay, now these are the informations we have, and on top of that we have the regular marshmallow creates 25 calories. I mean, if you have a regular marshmallow, you will gain 25 calories, so that's one thing. So that's 25 calories. And the question is, what's the calorie for the jumbo one? So that's X units, right? That's the unknown we're looking for. Let's write it in red. That's X calories. That's the unknown part. So these are the informations we have. Now we want to use the geometrical formulas and all that, and then we can solve it, okay? So by just eyeballing, can you guess what should we do? Don't look at the solution. It's pretty easy. You just need to understand what's going on here. Just eyeball it, see the information you have, and try to visualize how does that marshmallow look like? You know, which geometrical object we can relate this to. Okay, that's really important because the figure will not be given every time. Often you need to imagine, you know, because you can relate those to different objects. Obviously, you have already seen marshmallow. How does it look like? Anyone?
It's a cylinder.
And why do you think it should look like a cylinder? It could look like geometrical box. What made you think it should be a cylinder?
Because it's round and it has a circular top.
Very good, yeah. So if you can visualize the marshmallow, you can clearly relate this to a cylinder, right? Because it's roundish and it has a top and a bottom, right? Just look alike cylinder, right? So fortunately, this image is given, although it's not really clear. You can't really understand how does it look like. The reason I asked you is if you look at the jumbo one, it's actually looking like a box, right? So you need to know the actual size, not really size, actual dimension of it. Okay, how does it look like? You won't be given a problem with an object which you haven't seen or you can't really imagine. You know, okay, you haven't seen this before. You will not be given a problem like that. And if you are given a problem like that, the dimension will be more or less mentioned. Okay, if you can see the dimension, the given informations often actually direct you to a particular object. Okay, let's move on. So we have a cylinder and we have the diameter and the height of that cylinder, and associated with that we have calories. And definitely we are going to use this calorie in our proportions. So we're definitely going to take ratios where one thing is for sure will be calorie. Now what will be the other thing? That's the question. If you can understand it, the rest is pretty simple. We're definitely going to take the ratio of two things, right? One thing is going to be calories, that's for sure. What could be the other thing?
Is it volume?
And why?
I'm not sure.
Just go for it, even if you're wrong, no problems.
Because the calories aren't found in like the diameter or the radius or the height, but within the whole marshmallow.
Exactly, that's the exact word, whole marshmallow, right? The calorie is for the entire marshmallow. If you eat that marshmallow, you'll gain 25 calories. If you eat that entire marshmallow, right? So the entire marshmallow, the entire of a marshmallow signifies its volume. Can you see that, everyone? That's the most important part here, because the rest is just proportions and ratios. The calorie is actually for the entire marshmallow, and it's a 3D object, 3D thing, then we are actually considering the volume. So that means next thing is we need to find the volume. So the volume of the regular marshmallow and the volume of the jumbo marshmallow. Okay. The next thing is we need to know the formula, and the formula for the volume of cylinder is pi times the radius squared times the height. Okay. Now, can you see all the information in our question? And the answer is yes. That's the diameter. So what would be the radius? It would be half of that, right? So pi times 1.75, and we'll square it. What's the height of that? 3.5. Yeah, 3.5. And if we go for the next one, the diameter of that is 5.5. So it should be 2.75 because radius is half of the diameter, right? And the height is 5. The height is 5. So that's the volume of the regular marshmallow, and that's the volume of the jumbo marshmallow. Okay. Once again, I'll keep these pies rather, because I know when I'll set this up, I can easily cancel those. So let's do that setup part now. So clearly, on my left, I'll have volume over, oops, it should be calories. And on my right, I'll have volume over calories as well. So the first one would be pi times 1.75 squared times 3.5 over, what was the calorie again? 25, yeah, 25. And the next one would be pi times 2.75 squared times 5 over x, because we don't really know what's the calorie for the jumbo one, and we'll try to solve it. Okay, now let's solve it. We can cancel these pi's. Okay, and if we cross multiply this, it will be 1.75 squared times 3.5 times x. You can actually, meanwhile, you can actually find the result of this, the product. Okay, so that's this, and we'll have this as here. So it will be 25 times 2.75 squared times 5. Okay, so what's this? Anyone? What's 1.75 times 3.5?
It's 3.0625.
3.0625. And on my right, 25 times 5 times 2.75 squared. I think you got this wrong. Oh, I see.
I got 10.718.
Right, yeah.
Yeah, sorry, I didn't get my end result. I gave one before that.
Right, yeah. I was thinking that it should be more because we already have a 3 here, and we're multiplying it by something more than 1. So it should be more than 3 at least, okay? More than, yeah. So it's 10.718, 719, I should write 719 instead. 719, okay. Times x, and on my right I'll have, let me see, 25 times 5 times 2.75 squared. So that's 945.3125. Did I get this right?
Yeah.
Okay, so now I can isolate this x. This will be here because we will cross multiply it, if you remember. 3125 over 10.719. And the final result will be 719 is 88.1904. Okay, or you might write it 88.19, so you could write 88.2. Okay. Any question from this? We're not going to solve any more problems today, so if you have any question from this one, we can spend a couple of more minutes before we finish. So your next homework will be Try It Now 5 before we join on Friday. And on Friday, we'll have a review for the exam, for the first exam. I'll send you the study guide. It will be a smallish one. You can start practicing those and we can discuss more on Friday before we finally go for the exam. I'll send you the details of the exam once I have a meeting with the course coordinator tomorrow. But as of now, any question from this problem? All good? Okay then, so let's stop recording first. Okay.